Hey, I'm Elliot from SureCloud. This is the Back to Basics SQL injection episode. Let's go. We start by just manually exploring the site, clicking through menus and seeing what changes. Then editing the parameters in ways the programmer may not have expected, seeing if anything interesting happens, mainly looking for error messages or just weird behavior. Then we start to pry, fuzzing with a handful of special characters to see if we can trigger anything interesting. In a pen test, getting an SQL syntax error would be great. It means we can, at least in some way, affect the structure of the SQL query, more than just inputting the expected values. But a broken query is no use to us, so our first step is to try and make the syntax valid again. We do this by building a mental structure of what we think the query might look like, and manually crafting our input to rebuild enough of the query to make it valid again. In this case, we add the seeker string, enclose it with a double quote, and comment out the remaining server-controlled SQL query by adding a hash. We need to URL encode the hash symbol as %23, otherwise the browser interprets it as a fragment identifier and it doesn't get passed to the server. Now we try to gain more control over the query. We append a union select clause to our input. However, the union clause requires that we know the number of columns in the previous part of the query, which is currently hidden from us. We can try and brute force it until we stop getting errors. In this case, there's only 3 columns, so it doesn't take as long. At this point, we could start exfiltrating data such as password hashes or customer data, but this database doesn't contain any of that. So let's try something else. Instead, we can use the MySQL into out file clause to write the results of our query to the server's file system. Usually this is used to create CSVs, but we can use it to place a malicious PHP file onto the server by crafting our query to return a PHP web shell as a string, which we can then place anywhere on the victim server's file system. We can test to see if we have access to the file system by using into out file and dropping the current results of our query into the web root, which we may have to blindly guess. It's worth noting that this isn't something that will work in all cases. AppArmor and revoking the file privileges of the currently executing MySQL user will defend against this. But when it does work, it gives us full remote code execution on the server. After our web shell has been dropped, we can send commands as if we had terminal access as whatever user the web server is running as. We craft our SQL query to only return the PHP web shell. In some cases this may not be possible. There may be data that's always returned in the query. Exploitation is still possible in this case, but it may require browsing through the source to view the web shell output. When we choose which file to save as, we want to make sure that it ends with the extension .php, so the web server knows to interpret the file as a PHP file. We then browse to the location of our web shell and send the operating system commands we want the server to execute. From here we can start pivoting inside the network and attacking other servers that this one might be connected to. As you can see, it's not just the data within the SQL databases at risk, but potentially the entire network sitting behind the web server. And that about wraps it up for this video. Hopefully you've enjoyed it. Take care and have fun.